Hey guys, Mr. Betts here. I want to take a look at an example that combines instantaneous rate of change and average rate of change from a graphical perspective. So in this problem here, we are asked to find a value of C, or at least approximate a value of C, given this equation right here. So we know C is going to be somewhere between 2 and 8. So it's going to be somewhere on this interval where the graph of the function is shown here. And if we look at the two sides of the equation here, just one at a time, we will notice some things that are relevant to what we've been talking about recently. So on the left side of the equation here, this limit is the definition of the derivative. So we use this prime notation here. So what this is saying is that at this value C that we find, the derivative, or the slope of the tangent line, is going to be equal to something. And that's going to be equal to what we have on the right side. So on the right side, and I'm sorry about the sloppiness in here, but the right side, what we have here is a difference quotient that represents an average rate of change. And that's going to be the slope of the secant line. So in this particular example, that slope is going to be between the point at 2 f of 2 and 8 f of 8. So it's going to be the slope of the line connecting these two endpoints. So the slope of this line right here. Now, we're given enough information in this graph to compute that slope. We have these 2 points. So we have a point at 2, 1 and a point at 8, 4. So that slope then is going to be 4 minus 1 over 8 minus 2, which is 3/6 or 1/2. So essentially what this equation is asking for is there some point, or at what point is the slope of the tangent line going to be equal to 1/2? And with this being a multiple choice question, we don't have to do any computation. We're just going to use an estimation based on what the graph looks like at these points. So taking these points one at a time here, if we look at where C equals 3, so if C were equal to 3, the tangent line here is going to look something like this, and it's pretty clear, I think, that the slope of that line is not 1/2, because 1/2 is positive and we're getting a negative slope there. So I don't know what the slope is, but I know it's not a positive slope, so we can eliminate that option. If we look at C equals 4, at C equals 4, we're at the minimum value of the function there, and what we're going to end up with is actually a horizontal tangent. So the tangent line is horizontal, the slope of that horizontal line is going to be 0, so that's also not going to equal 1/2. Moving on to C equals 5. So if we say that we're at the point here at 5, the tangent line at this point, that does look like a pretty good option. We don't know exactly what the slope is there, but it does look like it's pretty close to 1/2, a slope of 1/2, which was the slope of this line right here. It looks to me like those two could be parallel, and I'm drawing this freehanded, so obviously there's a little bit of wiggle room with my slope at this point. So I think this is a good candidate, but I'm going to check our fourth option just to make sure. So at C equals 7, if our point of tangency here is at C equals 7, and we visualize a tangent line there, let me try drawing that again. It looks to me like the slope there is significantly bigger than 1/2. In fact, the slope there looks like it's more than 1. So it's pretty obvious that this slope, or the slope at that point, is not going to work. So by having this as a multiple choice question, we can estimate the derivative as the slope of the tangent line at each of these points and narrow it down to C equals 5.